How we got into this. In September 2010, my husband Sandy and I were driving up the Alaska Highway in early fall, and had planned to camp at a campsite near Fort Nelson that we had known from years earlier. When we got there, we did not recognize the area. What had been a small country road was now wide, covered with coarse gravel and barricaded with signs posted by Encana warning of sour gas wells and of no authorized access. Kind of like this sign up here. We knew this was a result of an escalation in oil and gas development in northern BC, but we wanted to find out what was really going on. And this is a picture of what was really going on. We discovered that Encana, together with Apache, which are very large oil and gas companies, had just completed the largest fracking operation on record in March 2010, just a couple of months before we were there, right there in the Horn Basin, northern BC. There's the Horn Basin, the inset. It's right at the very northeast of BC, and you can see where the Yukon is, not far away, in other words. This record was smashed in October that same year, about a month after we were there, by another Encana operation that used an estimated 1.8 million cubic meters of water, 78,400 tons of sand, and 36,000 cubic meters of toxic compounds. Those numbers can hardly even mean anything to us. They're so big. So fast forward 1.5 years, we and many other Yukoners were shocked to see a government ad appear in a local newspaper inviting oil and gas companies to explore for oil and gas in the Whitehorse Basin, which is also referred to as Whitehorse Trough. And it extends from the Carcross to Carmacks and includes Whitehorse. So we have the next slide. And so we can see the Whitehorse Trough, it's the red in the middle there, including Whitehorse. Liard Basin is over here in the corner. We can point to those, yeah. And then we have the Peel Basin up there, and I believe it's named, and the Eagle Plains Basin, and a few other large ones. The Whitehorse Basin and the Peel Basin and the Liard Basin are not, we are not having oil and gas activity there for reasons that you'll hear just in a minute. So fortunately, oh right, and then we had, this was followed by open houses. So we all got to go to open houses where we got the real story. So that along with other Yukon basins that were open for exploration, that they consisted mainly of shale, which would require the use of the non-conventional extraction method, hydraulic fracturing, which Dr. Ingraffea is going to talk to you about tonight, involving the huge quantities of water that I just spoke of a bit earlier. Fortunately, as a result of much public outcry, and many of you will remember this, a 5-year moratorium on oil and gas development was placed on the Whitehorse Basin in 2012. So we have another year or so to go. This gave us some time to educate ourselves about the industry that was being invited into the territory. At this point, a small group of Yukon residents got together and formed Yukoners Concerned about Oil and Gas Exploration and Development. We have about 250 members now. We set to the task of learning about fracking, this non-conventional method of extracting oil and gas. We read scientific papers, contacted researchers, scientists, individuals, and groups to find out about experiences in BC, Alberta, other parts of Canada, the United States, and across the world, because this is a problem across the world. The more we researched, the more we realized that oil and gas exploration and development involving the use of hydraulic fracturing in particular, it poses serious threats and harm to everything: water, land, air, health of humans, health of wildlife, as well as serious social and cultural consequences. The next slide. There is also the intensity with which this industry operates. It marches across the landscape. Wells are relatively short-lived, and new wells must be drilled, producing spatial build-out that is difficult to stop once it ramps up. This is an example of what it looks like in Texas from I forget how many feet high, but 3,000? 30,000. Fracking and disposal of waste in oil abandoned wells also cause earthquakes, and we know that now from recent research. We also found that this industry contributes significantly to climate warming through emissions of greenhouse gases, including methane. And this is a problem that is poorly monitored and not well documented at this point. So we had all this information. So we shared our findings through a science-based presentation, which we took to groups and communities throughout the Yukon. So we dealt with important topics related to hydraulic fracturing. And these are some of the topics that we dealt with, and some of you may have attended some of those presentations. We also arranged for professionals to come and share their knowledge, their experiences, and their words of warning with us. We heard from climatologists, hydrologists, earth scientists, engineers, economists, lawyers, and many other ists. We participated in rallies, attended government legislature sessions, and connected with First Nations as much as we could. We attended and wrote submissions to the hearings held by the Yukon Select Committee on risks and benefits of fracking. We went door to door to talk about fracking in oil and gas development and have collected more than 8,000 signatures on a petition to ban fracking in the Yukon. We have lobbied our city to ban fracking within its boundaries and have urged them to investigate the safety of having drill cuttings and fluids disposed of in our city, and of the importance of having radioactivity levels of this waste properly tested. We have written submissions to YESA and followed environmental assessments of proposed oil and gas projects in Eagle Plains and in the Liard Basin. And we have traveled to areas of BC where oil and gas development has really taken its toll. We have flown over portions of Eagle Plains in northern Yukon, where exploration has been underway for a few years now. And this exploration is happening around the Dempster Highway there, in just a couple of those sections. But you'll notice that there are permits for 15 sections. And so when one gets explored, the others can start. So it just goes on and on. Eagle Plains is a particular concern because it is the overwintering habitat of one of the largest herds of barren ground caribou in the world, the porcupine caribou herd. You can see here that there has already been significant human disturbance, cut lines, seismic lines, in their winter range. All this, those are all cut lines or seismic lines that already exist in exactly the winter habitat of this herd. It is also important to note that being so far north, this is an area of continuous permafrost. And there is little available information on how this type of industry will impact Ingraffea has some more to say about that, I hope. There are alternatives to the development of oil and gas. We are currently learning all we can about renewable energy by organizing and attending workshops and seeking out ways to collaborate with other groups and communities across Canada and beyond to find out about renewables that would work here in the Yukon. Exciting things are happening in this field, and we at Yukoners Concerned and many other people in our community want to be part of that. The Yukon Party government, however, has recently released its 2016 updated action plan to develop oil and gas in two of the Yukon's large shale basins, the Eagle Plains, which you can see up there, and the Liard Basin. which is very close to the first slide that I showed you down at the southeast corner. This will likely mean the use of hydraulic fracturing, even though they are careful not to use that term. This despite the fact that many Yukoners do not want it. And despite the fact that Canada has not addressed its emission problem in our fight against global warming. And this, despite the fact that we have globally just had the hottest 16 consecutive months on record. We really have no business developing new oil and gas reserves in the Yukon or anywhere else in Canada if we are serious about addressing climate change. Pure and simple, the science has made it clear that this planet cannot afford the added emissions. That brings us to this fall when we will need to make an educated choice the coming election as to what legacy we want to leave for the Yukon. And I'll just leave you now with a short video by Gordon Gilgan. Thank you.
Thanks, Lois. And we just wanted to let you know that that video is on YouTube if you want to look at it or show it to anyone. I wanted to mention that there is a sign-up sheet in the lobby, so if you'd like to leave your email address with us so that you can receive the Yukoners Concerned newsletter, please do that.
Good evening, everybody. Welcome to the Bringia Centre. My name's Sebastian Jones, and I'm an energy analyst with Yukon Conservation Society. And I want to start this evening just by acknowledging that we're here on the traditional territory of the Taan Kachan Council and the Kwanmin Dun First Nation. And is Sean here?
And there will be a
Sean?
donation jar in the lobby that looks like that drawing working. It costs money to do all of these things, and we're doing our best to keep costs down, but we do rely on donations from people to keep the work happening. Now it's my pleasure to tell you a little bit about Dr. Ingraffea. Dr. Anthony Ingraffea is a scientist with answers to the key questions about fracking. And he's also a very concerned citizen dedicated to raising awareness about the dangers of unconventional oil and gas development. He once worked as an oil and gas industry insider, but grew so alarmed with what he was seeing that he became a vocal opponent of fracking. Tonight, he will present an overview of the science of shale gas development and the... I don't know what's happening. Am I too close to something? He'll present an overview of the science of shale gas development and the harms of fracking. Dr. Ingraffea is a professor of engineering emeritus and presidential teaching fellow at Cornell University in New York State, as well as president of Physicians, Scientists, and Engineers for Healthy Energy. He was named co-editor-in-chief of Engineering Fracture Mechanics in 2005 and received the ASTM Irwin Award for meritorious contributions to the practice of fracture mechanics in 2006. Dr. Ingraffea was named a Fellow of the International Congress on Fracking in 2009. And in 2011, Time magazine named him one of its people who matter. Well, Dr. Ingraffea, you matter very much to us. Thank you for taking your time to be with us, and we especially appreciate your willingness to begin your talk at this time of day, as we know that it's after 9:30 p.m. in your neck of the woods. We have time now to hear from Dr. Ingraffea, so I will let you take it from here. Thank you.
Are we ready to start?
Yeah, we can start.
Okay. Good evening, everyone. I really would like to be there with you in Whitehorse, but it's a bit of a commute from upstate New York, so we're going to do the best we can with modern technology. I want to thank all of you who are in the audience and also those of you who are viewing this through live streaming. It's a great honor, and I think it's a privilege for me to be addressing you tonight, and I'm looking forward not only to speaking to you, but to hearing from you during hopefully what will be an also very informative question and answer session when I'm done with this formal presentation. So let me begin by telling you what we're going to do, and then we'll do it. So the first thing I'm going to do is answer some of the questions that you have sent to me. With the various communications I've had with the organizers of this session, I received a long list of questions, and it turns out that I had already intended to address some of them, so it's perfectly timely, and it's obvious to me that many of you have done your homework. So I'm going to begin by answering some of those questions up front, but I'll answer all of them during the talk that I'm going to give you. Then I'm going to go into what is new for oil and gas in the Yukon. There has been oil and gas development in the Yukon in the past. Why is there a concern now? Why is there more concern now? And then I'm going to give significant details on what it takes to get gas and oil out of shale, because that is what's new. How to get gas and oil out of shale. Fracking is one part of it, but it's not everything. Then I'm going to spend some time talking about what can and does go wrong during this process of getting oil and gas out of shale. I'll concentrate on two specific things in that area. And finally, I want to summarize what the science, the peer-reviewed, highly vetted, prestigious science says about the negative impacts on water, on air, and on human health due to the development of shale gas and oil. So that's what we're going to do over the next 8 or 9 hours. It's okay that we start at 9:30 at night. You people are still having early evening. I can go forever. So here's the list of some of the questions you sent. And I'm going to begin by addressing the first two. So I'll read the questions and I'll give you my answers. So I've been told by you that there's been some misleading information about conventional versus unconventional development. Some people are saying they're the same thing. So you want me to explain the difference, and I will. And by the way, I'm not at all surprised that there's misleading information. Welcome to the club. And related to that question is a second one, which is it true that fracking, which is also called well injection, which is also called hydraulic fracture stimulation, is it true that it only happens in conventional wells or only happens in unconventional wells? So let's address those two questions first, and they will be a lead-in to my answering some of the other questions and other things I wanted to talk to you about tonight. So, formal definition. If you were to go to the oil and gas industry Bible, it's put out by a company called Schlumberger. It's called the Oil and Gas Field Glossary. Any definition of any term that you would ever want to get in the oil and gas field, you can go on the website, there's the URL, and get it exactly from the horse's mouth. So how does one define today what is unconventional as opposed to conventional? And this is word for word the definition, and I've highlighted the key words. At present, the term unconventional is used in reference to oil and gas resources whose porosity, permeability, and fluid trapping mechanism differ from conventional sandstone and carbonate reservoirs. Let me translate that. Conventional oil and gas comes from sandstone or carbonate reservoirs where it has been trapped. Carbonate reservoirs, sandstone reservoirs do not create oil and gas, they trap it. On the other hand, what's currently called unconventional means it's either coal bed methane, gas hydrates, shale gas, fractured reservoirs, and tight gas sands. So since we're talking tonight about shale gas, and since you can only get gas out of shale if its reservoir is fractured, we are talking about unconventional oil and gas development. So let me repeat. Conventional means that the oil and gas has migrated from someplace else and has become trapped in a sandstone or carbonate reservoir. When we're talking about shale, shale is the source of oil and gas. It's where it comes from. It has not migrated out of the shale. It's still there. And when you develop an unconventional oil or gas well in shale, you're trying to get the gas and oil from its original source. I hope that's clear. If it isn't, you can ask me questions later. So related to this issue of conventional versus unconventional, and this is very confusing, so I'm going to try to unconfuse you, is the issue of fracking. So the question I got was, is it true that hydraulic fracture stimulation, also called well injection, also called fracking, only happens in conventional wells? No. No. Fracking can and does occur in both conventional wells and in unconventional wells. The difference is, for you in the Yukon concerned about shale, that it is possible to get oil and gas out of a conventional well without fracking. Even though most conventional wells today are fracked, it is sometimes possible to get oil and gas out of a conventional well without fracking. But it is impossible to get any economically viable volume of oil or gas out of shale without fracking, which is another way of saying all shale gas and oil wells must be fracked. In fact, they must be super fracked. And I'll get to that difference between fracking and super fracking in a few minutes. So again, I hope I've answered that question. Next question. Could I please explain what a perfing gun is and how it is used? Perfing. Well, first of all, perfing is an abbreviation for perforating, as in take a piece of paper and punch your finger through it, or punch a pencil through it. You're perforating the paper. Except in oil and gas, we're not perforating paper. So the purpose of perforating is to burn holes in what's called the well liner, also called casing. It's steel pipe. As you'll see in a few slides when I actually blow up a well and show you what's inside of it. And very important part of the structure of an oil or gas well is layers concentric layers of steel pipe called casing. Well, you can't get gas or oil to come into steel casing unless you put holes in it. And you can't fracture the rock, you can't put fracking fluid out into the shale without having holes in the casing. So the purpose of a perforating gun is to, quote, shoot, although it really doesn't shoot a solid, it shoots a very, very high temperature liquid into the casing, burns through the casing, and burns a hole into the rock. The whole idea is to give access for fracking fluid to go out of the casing and for oil and gas to flow back in. So what are these perforating things? They're not really, the word gun is, one thinks about bullets, but there's no bullets here. You're not shooting a solid. They're shooting a very high velocity jet of liquid copper. So I'm not going to go through the details on this slide. You can go to the website, the Oil Field Review by Schlumberger. It'll give you all kinds of details. They're basically shaped charges. Those of you who have been in the military or have followed the military or read about military books, shaped charges are used, for example, to penetrate armor in the military. Not with a solid, but with a high velocity, high temperature liquid metal, in this case copper. So that's what perfing is done. That's a perfing gun. That's what is necessary during the fracturing process. Thousands of holes need to be burned through the casing in a typical shale gas well. So thousands of these shaped charges have to be created, transported, stored, dropped down into the well, placed exactly so that they get the holes in the right place, in the right orientation. So let me show you, by taking apart a well, all these components that I've been mentioning, like casing and perforating and cementing. So this is an experiment I was involved in some years ago. You can see the date on it, July 1989. I had black hair back then, and my kids were still kids. We did laboratory testing down in Utah on large blocks of sandstone. So this is a conventional rock. This is a rock that would have absorbed gas or oil from shale. And we purposely did these experiments to try to understand the process of hydraulic fracturing. So this is a cube of sandstone, roughly 2 meters on a side, and we drilled it, we put casing in it, we cemented the casing, we put a perfing gun in it, we perforated the casing, we injected hydraulic fracturing fluid, and we fracked it. So this is what we found when we broke open that block. I'm going to break that block in half and show you what's inside. So on your left, you'll see this silver casing, that's the steel pipe. You'll see that it's surrounded by a gray layer, and that's cement. The same kind of cement you would get by going to your local hardware store and buying a sack of cement, mixing it with water. It's not concrete. It's cement powder mixed with water and other chemicals. And here you can see perforations. There's a hole here that went through the casing and into the rock. There's a hole in the casing here that went into the rock. Here you can see a hole that went through the casing in the cement. Here you can see a tip of a perforation out in the rock. In this red area is a hydraulic fracture. We put red dye in the fracturing fluid so that we could see the actual hydraulic fracture shape and propagation. So there's the basic elements of a gas or oil well: casing, cement, perforations, rock. Next question I'm going to answer right up front. To my knowledge, does fracking cause earthquakes? Yup, yes, definitely, for sure. In 2 ways. Indirectly and directly. By indirectly, I mean that when a well is fracked, and a typical shale gas well in British Columbia is fracked with 40 or 50 million gallons, I should say liters, 40 or 50 million liters of fracking fluid. Much of that fluid comes back up the well after the fracking process, and that's called flowback. So that's a waste. It's no longer drinking water. It's now wastewater. It's contaminated. So it has to be captured, and it has to be stored, it has to be transported, and it has to be put someplace safe forever. In the United States, in most cases, it's re-injected back underground in a waste disposal well. A waste disposal well is typically an old oil or gas well that is no longer producing oil or gas. So it's now capable of receiving large volumes of waste fluid. The problem is that this process has been overdone. Overdone in places like Oklahoma, Texas, Arkansas, Ohio, and England, among others. And in the process of injecting down underground, deep underground, large volumes of this waste fluid at high pressure, faults, naturally occurring faults in the earth, have been mobilized. So hold your hands together. I can't see you, but take your hands and put them together as if you're going to clap. All right? So between your hands is a fault. That's a crack. It's a natural crack. Now, slide your hands relative to each other. You just made an earthquake. Now, when you inject fluid underground and that fluid gets into that fault, your hands become slippery and they slide easier. And if you inject the fluid under too high a pressure, you basically take the pressure off of your hands so that they're barely touching, and now they're easier to slide. There you go. Human-made earthquakes in 15 seconds, using your hands. So how often has this happened? Well, in Oklahoma, I'm showing you a plot here that says in 2000, there was exactly one earthquake of magnitude 3 or greater. In 2015, there were 680. Notice starting in 2009, the drastic increase in earthquake activity in a place where there had never been any significant earthquake activity. It just so happens that that's the period of time in which shale gas and super fracking came into play in the United States. Not only in Oklahoma, but a number of other states. So much so that now the United States Geological Survey, which issues maps of earthquake intensity and earthquake risk, now shows that the area in Oklahoma and Kansas and Arkansas and Texas, where there has been a large amount of shale gas and oil fracking and waste disposal, has very high risk of earthquakes. We've now made Oklahoma as risky as San Francisco. Thank you, oil and gas. I'm sure the people of Oklahoma really appreciate what you've done for them. Second way that earthquakes can happen is directly by fracking. Fracking itself is, by definition, fracturing. Fracturing, by definition, is an earthquake. So, there have been many instances of fracking directly causing earthquakes, most notably not too far south of you in the Horn River area of British Columbia. So in December of last year, there was a 4.6 magnitude earthquake. At that point, the largest man-made earthquake ever recorded. I said the largest man-made earthquake ever recorded from oil and gas operations. Not quite a year ago. And I then found out that that wasn't the world's largest because in January of this year in Alberta, a 4.8 occurred. So 4.6s and 4.8s are not going to shake buildings to the ground, but they are going to crack walls. They're going to induce settlement. They're going to knock things off of shelves, and they could injure people. The question now that the earthquake scientists are considering, and this is a very important problem, and they're very worried, what's the upper end? How large an earthquake can be caused either indirectly or directly? What we've seen over the last 7 or 8 years is that the magnitudes keep increasing. 7 or 8 years ago, the oil and gas industry was absolutely certain that they had never caused an earthquake. Never. In Texas, they still say that they don't cause earthquakes, but that's Texas. They're a different country. But all of the scientists, all the prestigious, real, honest-to-goodness scientists in the earthquake area are absolutely convinced that oil and gas operations now cause earthquakes with increasing frequency and with increasing maximum magnitude. And we are at risk in the US, and you are at risk in British Columbia, of having a significant earthquake, a 5.5, a 5.6. Okay, a 5.6 is 10 times stronger than a 4.6. Buildings will collapse. There are two other questions I'm going to address, but I'm not going to do them right now. They will be addressed later as my talk develops. I'm going to talk about climate change, and I'm going to talk about the downsides of hydraulic fracture stimulation and the downsides of waste from hydraulic fracturing. So I will answer those last two questions, and you'll hear the answers later on in my talk. So let's proceed now back to my outline. The first thing I want to do is answer the questions you sent me so we get all the definitions and all the incorrect notions and misinformation out of your minds. Now you have it from, quote, the horse's mouth. Everything I just said is correct and true. And by the way, I hope that there are oil and gas representatives listening to this presentation somewhere. And if you hear me say something that you think is incorrect, please contact me directly and we will discuss it. I don't want you doing what they do in the US, which is you go on your stupid blogs and you criticize my talk without my opportunity to engage with you. Be professional. If you think I'm saying something incorrect, tell me to my face. So, what is new for oil and gas in Yukon? I already told you. What's new is shale. Now, how do you get oil and gas out of shale? I'm going to use a bunch of pictures and videos and graphs and charts taken directly from the oil and gas industry. You'll see that this chart that I'm showing you right now was created by Chesapeake and Statoil, two major companies, trying to explain to their shareholders the process of getting oil and gas out of shale. So I'm going to spend a minute or two explaining it to you because this is really important. This is unconventional development of oil and gas from shale in one picture. So here's the surface of the earth. Down here, this gray box is a layer of shale. Shale occurs in layers over very, very large expanses, many hundreds of kilometers in every direction. So here's all your shale. Here's the surface. On the surface in this picture, there are 4 pads. A pad is a place where the drilling occurs. I'll show you pictures of pads. But here's a pad, here's a pad, here's a pad, and here's a pad. Now, to get oil and gas out of shale, you can't just drill directly vertically down. That's what you would do in sandstone or a carbonate reservoir because the oil and gas would be trapped in a pool directly below your wellhead. But in shale, the gas and oil is distributed. It's everywhere in the shale. So since the oil and gas is everywhere in the shale, you have to drill everywhere in the shale. So in each pad here, there's not 1 well, but 6 wells. And they start off coming down vertically, and then they deviate. This is called deviated drilling. So nowadays they can drill well in any direction they want. So they start off vertical, then they curve, and they go more or less horizontal so that the well is along the shale, not through or into the shale. So this is called the lateral. And all these little fuzzy spaces here are supposed to be fracking. So we frack the shale here, we frack the shale here, frack the shale here, and you'll notice that these laterals can be over 2 kilometers long. But they're only about 150 meters apart because the idea is to try to drain as much oil or gas as possible out of this volume of shale. You'll notice the distances here. So on the surface, in one direction, the pads are only about 1.5 kilometers apart. In the other direction, they're about 3 kilometers apart. This yellow box is meant to indicate all of the surface area that this particular pad would account for. It's called a development unit or a spacing unit. So a company gets a permit to put a pad, put 6, 8, 10 wells on that pad, and try to get all the oil or gas beneath that yellow square. And I'll show you what those yellow squares do in a few minutes. But what this picture captures is the essence of unconventional development of oil and gas from shale. It is the only way that has been developed, and I predict the only way that will ever be developed, to get, hopefully, economically viable volumes of oil or gas out of a shale formation. And what you're seeing is what's called clustered multi-well pads with high volume long laterals. It's not called fracking in my terminology. That's too short a word. You got to use all the right words. Clustered means, look, 1, 2, 3, 4, and there would be more over here and more over here and more over here. Multi-well, every pad has many wells. 6, 8, 10, 12, 20 wells. High volume, I mentioned 20 to 50 million liters of fluid being injected into each of these wells. Long laterals, 2 kilometers or more. So, having done all that, the problem is that this whole process is very inefficient. Industry isn't going to tell you that. You should ask, what percentage of the gas owned by the province, what percentage of the gas in the shale formation are you actually going to produce? Or what percentage of the oil are you going to produce? And they should be honest and tell you, well, we're probably at best going to get 10% of the gas and about maybe 3 or 4% of the oil. So all that effort, tens of millions of dollars on each well, all that fracking, all that heavy equipment, all the infrastructure that we're going to see, all the pipelines, all the compressor stations, all the processing units, all the truck traffic, all the new roads, all the new pipelines, and they're only getting a very small fraction of what's there. Why? Because shale is stingy. Shale is mean-spirited. Shale is getting even with humans. I'm lecturing here from my pulpit. Shale is getting even with humans because it's angry that it was the last kind of rock that the oil and gas industry went to. It's been lonely for 150 years. It's been waiting for the oil and gas industry to come and take it. And because it waited, it's like the poor guy who was hoping that the most beautiful girl at the dance was going to come and ask him to dance, but she never came over, and now he's really upset. So I'm joking here, but the point is that it's very, very difficult to get oil or gas out of shale. That's one of the reasons the oil and gas industry waited until the end of the fossil fuel era. It's very expensive, it's very difficult, and yet it's still very inefficient. So the best they can do is to use 2 approaches, spatial intensity and technologies of scale. By spatially intense, I mean you have to have a hell of a lot of pads with a hell of a lot of wells in any one area. As I just showed you, you have to drill everywhere. Drill as many wells as you possibly can in any one area to try to get as much oil or gas out of it as you can. Technologies of scale means that compared to conventional wells, where the oil and gas had accumulated in one place, everything is bigger. Everything is bigger with shale. And I'll list all the things, and I'll tell you about how much bigger they are in a few minutes. So what do I mean by spatially intense? If you were flying over Texas in the area around Dallas and Fort Worth, Dallas and Fort Worth are a few kilometers off to your right in this map. Here's your scale. This is 4 kilometers. Every one of these white dots is a pad. I repeat, every one of these white dots is a pad. And every one of these pads has many wells. So there have been 15,000, actually more now, there are 18,000 wells drilled in the Barnett Shale play, just to the west and north of Dallas-Fort Worth. I'm going to blow this up so you get a better view. So now I've gone to a 1 kilometer scale, and again, each of these white dots is a pad. And as you can see, more or less 1 or 2 kilometers between each of the pads. So now I'm going to ask you to use your imagination. If there's going to be shale gas or oil development in the Yukon, is it going to look like this? Must it look like this? Is there some other way to do it? It will look like this. There is no other way to do it. So let's transport ourselves into the future. Hopefully a not true future. But let's go to the Yukon. And let's go to some area south of where you're sitting. Here's Whitehorse. We're going to go down here near Carcross. And this is an area that's been designated as an unconventional resource. Here are shales. So let's go into this red box. So this is the area inside that red box. Here's Carcross, Route 2. Now remember that yellow square I showed you around the pad on that image I showed 3 or 4 minutes ago? Let's start putting pads in this area at the same spacing that I told you must be used, that the industry would like to use for clustered multi-well pad development. Bingo. Every one of these yellow rectangles is a spacing unit or development unit for a pad. Each one of these red dots is a pad. And the idea is you don't leave any stone unturned, pardon the pun. You want to drill everywhere. If there's gas or oil everywhere in the shale here, you want to drill everywhere. And so from each of these pads, there would be 4, 6, 8, 10, 12 wells. Depends upon the geology and how much money they have. Now, as you heard a few minutes ago, the previous speaker mentioned that these wells deplete very quickly. A shale gas or oil well runs out of gas, pardon the pun, in 4 or 5 years. After 4 or 5 years, it's a stripper oil well or a defunct gas well. Turn it off. It's not worth maintaining. So a company will come in and drill the first 2 or 3 wells from this pad, and then go off and drill 2 or 3 wells from this pad, and then 2 or 3 wells from this pad, 2 or 3 from here, 2 or 3 from here, and then come back 2 or 3 years later and do 2 more here, 2 more here, 2 more here. In other words, they're going to be around a long time drilling. Years. That's another difference between conventional and unconventional. A conventional well, you drill, you move away. There's only one well. In unconventional, you're back again and again and again. Technologies of scale. So I told you everything is bigger compared to conventional. You need the largest drill rigs in existence. They're called triples, with very large horsepower diesel engines driving the drilling motor. You need much larger fracking equipment. You're fracking at pressures that are 3 or 4 times higher than conventional wells. You're using 100 times more fracking fluid than a conventional well. And you're using 10 times the horsepower for the pumps, typically 15 to 20,000 horsepower necessary in a frac job. Because you're using so much fracking fluid, you get a much higher volume of waste fluid called flowback. You're going to have larger and longer flaring and venting. And by the way, I have read your regulations for Yukon, and frankly, they are wanting. They do allow flaring and venting. Venting is direct emission of methane into the atmosphere during flowback. I'll show you a picture of flaring in a few minutes. A lot more truck traffic because you have to transport large volumes of water and large volumes of fracking fluids and large volumes of sand and a hell of a lot of equipment to each pad multiple times. Not just once, multiple times, because they're not going to do all 8 wells in a pad at the same time. You got to connect every well with a pipeline. If it's a gas well, the only way to get the gas out of the well is into a pipe. So you got to create pipelines. Every well has to be connected by pipeline to a compressor, to a dehumidifier, and if it's wet gas, to a processing unit. So you're going to need compressor stations. I'll show you pictures of what those look like and some of the bad things they do. So more and larger compressor stations compared to conventional, and more and larger processing plants if you have wet gas. And of course, much higher greenhouse gas emissions, and we'll spend time talking about that. So, what does a pad look like? I showed you an artist's rendition. This is the real thing. This is a photograph of one of the largest pads ever. It's in British Columbia, not far from where you're sitting. And in my opinion, British Columbia has always been the experimental playground for shale gas development, because there aren't too many people around. And you'll notice there's been a tremendous amount of tree removal, a large amount of earth moving. Here's your freshwater pit to store water for the fracking process going down, and here's your wastewater pits, take the flow back, coming back up. So all this waste has to go someplace, and you better be asking the people who want to drill in the Yukon, what are they going to do with it? Do you have injection wells in the Yukon? Has anybody checked to see if they're on fault systems? And if you don't have injection wells, where are you going to put all this stuff? So this is probably a 15 or 20 well pad. And when I say that the British Columbia has been a testing ground, this is British Columbia, this is Pennsylvania. Look familiar? Large amount of tree removal. And by the way, trees are called carbon capture and sequestration units. Talking about climate change here. This is called burning your candle at both ends. You're killing a large amount of trees, and the trees are there to absorb carbon dioxide, and you're producing a large amount of gas, which produces a large amount of carbon dioxide. Bad news at both ends. Flowback impoundment that you saw up in British Columbia, here's a flowback impoundment in Pennsylvania. Notice the close proximity to human habitation. This is toxic material, liquid and gas. Here's a flare. I hope you get the scale here. Flaring means you're burning off the gas that's coming up of the well, whether it's an oil well or a gas well, during the flowback period after fracking for a few days or a few weeks. They don't capture the gas, they vent it or they flare it. This flare is over 100 meters high. And I wish I could show you what the sound is that it makes, but it lights up the countryside. And it has the sound of a jet engine continuously for days. Very disruptive of sleep patterns, disturbing children and animal life. Compressor stations. When the gas comes out of the well, it might not be at a high enough pressure to enter a transmission pipeline. So the gas has to be increased in pressure with a compressor station. Inside these buildings are 2,000 horsepower pumps that are pumping up the pressure in the gas. As more and more wells are built, and as more and more pads are built, compressor stations become larger. So here's a more modern version of a compressor station. 1, 2, 3, 4, 5, 6, 12 buildings, each of which contains two 2,000 horsepower pumps. They make a lot of noise. They emit a lot of greenhouse gases. And sometimes they have accidents called blowdowns. So I'm going to show you a video. And Jason, if you can cue up the first video at this point. This video is what's called a blowdown event. There's an overpressurization in the compressor station, and an emergency valve kicks off, and a very large volume of methane, natural gas, is emitted into the atmosphere directly. Let me know when the video has started.
We're going to start it right now if it works.
Okay. Is it going? Good.
Been going on for half an hour now.
So this throwdown event in this particular case was in Pennsylvania, not far from where I live now, and it lasted for over an hour. And I hope you can hear that very loud noise it's making. It echoes around the countryside. You can hear it from miles away. And literally thousands of cubic meters of methane are vented directly into the atmosphere. This is not uncommon. You have compressor stations built in your area, you should expect to see this happening. Okay, you can shut that one down, Jason. I mentioned processing plants. These are mini refineries. If it turns out that the natural gas that you have is wet, which means it's not just methane, it would have propane, butane, ethane, higher order, what are called alkanes, then all those different kinds of gases and liquids have to be separated. That's what's called processing. And these processing plants are also large industrial complexes. These are in West Virginia, Ohio, and Pennsylvania. So, bottom line, shale gas and oil requires a large number of multi-well clustered pads in what I call significant ancillary infrastructure. By ancillary infrastructure, I mean pipelines, compressor stations, processing units, dehumidification units, storage units. In other words, you take an area like south of Whitehorse and you take bucolic countryside, which is what it looks like from Google Earth, and you turn it into an industrial complex. If that's what you want, vote for it. Next topic, what can and does go wrong? I'm going to pick two things. Many other things I could talk about, might come up during Q&A, but I'm going to pick two things. Drinking water contamination and methane emissions into the atmosphere. So we'll start with drinking water contamination. So what you're looking at now is a picture, a still image, of a wellhead. This is where the steel casing that I showed you before comes out of the ground at the surface, and there should be gas coming up the inside of this steel pipe and going into a pipeline. And I'm going to ask Jason to run this video, and what you're going to see is this pipe coming out of the ground, going into a pipeline, but you're going to see that the gas is not only coming up inside the pipe, it's coming up outside the pipe. Go ahead and do that video. And let me know when it started. Thank you. So you'll see that there's been water collecting around the wellhead. That's probably snow melt or rainwater. And that bubbling you see is methane gas that's leaking outside the well, coming up into that water, and it looks like it's boiling the water, but it's just gas, like fizz in your fizzy soda drink. And that's methane going into the atmosphere. But it's also going through the groundwater table. So if the gas is leaking outside the well and it's getting to the surface, that means it had to go through the groundwater, which means the methane is now contaminating a drinking water supply. This is bad. And it happens too frequently. You can stop that video now, Jason. Thank you again. So how frequently does it happen? Depends upon how well the well is built. So these are videos created by another large gas company, Southwestern Energy, to show the good, the bad, and the ugly. So here's the wellhead, here's the casing, the gray is the cement, here's your shale formation, but usually when you have one shale formation, you have multiple shale formations, and you might want to be getting the gas out of this formation, the lowest one, but there's also gas in the other ones. And so if your well is correctly constructed, you have cement acting as a gasket so that the gas in this layer of shale can't get into the well. The cement is doing a good job. The gas is only coming out of the producing formation going to the surface. Bad things can happen. One of the bad things that happens all too frequently is the cement job is bad. And the cement job can be bad for many reasons, and the industry knows it. There are literally 5,000 publications that I'm aware of in the industry compendium talking about bad wells, leaking wells. So if the cement is not doing its job as a gasket, then gas from these intermediate formations can get outside of the casing that's supposed to be transporting the gas. And if the gas is not allowed to vent into the atmosphere, and it should, by your regulations, the gas is supposed to vent into the atmosphere, but if that vent is somehow blocked off or frozen, pressure builds up, the gas migrates into an underground source of drinking water, and your well water goes bad. You can have a casing failure, corrosion, cracking. Again, casing fails, gas leaks out of the casing, same thing can happen. The gas can get into an underground source of drinking water. Or maybe the cement didn't go where it was supposed to go. It's not like you can go down the well and look. There are technologies that can be used to investigate whether a well is well constructed or not. Some regulations require them, other regulations do not. You might not know until the well goes bad that it had a bad cement job. And then it's very expensive and sometimes impossible to fix the well. How often does this happen? We published a paper a few years ago looking at the frequency of occurrence of leaking wells in Pennsylvania. And what we found is that unconventional wells were failing at a rate of about 6.2%. 1 out of every 16 modern shale gas wells, modern, in a state which has very tough regulations, much tougher than the regulations in the Yukon. 1 out of 16 wells was failing within the first 3 years. And in some places in Pennsylvania, 1 out of 10 was failing in the first 3 years. That's a lot of leaking methane. And we'll talk about what that's done next. So back in 2011, I was privileged to be a co-author on a paper that caused some consternation, some controversy. We published a paper in which we said that shale gas, when compared to conventional gas or coal or oil, was the worst possible thing for climate. So I'm not going to try to explain the units here, but the taller these columns, the worse it is for climate. And this pink is methane, the blue is CO2 indirect, and the black is direct, meaning when you burn it, you get CO2. All those diesel engines burning diesel create CO2. So we said that shale gas was emitting into the atmosphere, unburned, somewhere between 3.6 and 7.9% of all the shale gas produced in the U.S. was never being burned. It was just getting into the atmosphere, leaking, venting. And that made shale gas the worst possible fossil fuel from a climate change perspective. And in 2011, we were pilloried. Even the White House criticized us. Said it can't be true, impossible. Fast forward. 3 years later, our White House publishes 2 major reports. Climate change impacts in the U.S., a whole chapter on methane emissions. And then an entire new plan, a climate action plan, strategy to reduce methane emissions. Oops, we were right. Every paper that's been published since 2012, in which people actually went out and measured methane emissions from oil and gas operations in the United States, has shown that that range that we predicted captures what's actually being measured. Okay, well, if this is true, if there is a lot of methane getting into the atmosphere, we should see it when we measure methane concentration in the atmosphere. And if you didn't know this, you're going to find out tonight. There is only one place on the face of the earth, one place, on an island in the Hawaiian chain out in the middle of the Pacific Ocean, where the United States government, in cooperation with governments all around the world, including the Canadian government, makes official measurements of the concentration of carbon dioxide in the atmosphere and methane in the atmosphere. And this is a record starting in 1960 of the concentration of carbon dioxide in the atmosphere. And you'll notice that last year we blew by 400 parts per million. We're on our way to 420 within another 2 or 3 years. That's carbon dioxide. Here's methane. This is the concentration of methane in the atmosphere by year. Notice that somewhere around 2002, 2004, here's 2006. Methane concentration in the atmosphere had sort of flattened out. But starting in 2006, what happened in 2006? Somebody answer. What started to happen in the U.S. in 2006? Yeah, shale gas development, shale oil development. 50,000 oil and shale gas and shale oil wells drilled in the U.S. since 2006. Is this a coincidence? The industry says yes. They say this is coming from cow farts or rice paddies. But the most recent paper published just last week has used modern detective methods, modern chemical methods, looking at isotopes of the various components of gases in the atmosphere. And that paper is the first to show very, very positive evidence that this is due to increased methane emissions from oil and gas operations in the United States. My country, this is global. This isn't methane concentration across the U.S. This is methane concentration in the atmosphere of our planet. So, geez, you know, the White House was really critical of us in 2011, but now here it is 2016, our Environmental Protection Agency is taking steps to cut methane emissions from oil and gas sources. Well, whoopee. Took them 5 years. And I'd be remiss if I didn't show you a picture of your premier and our president at a meeting earlier this year where they agreed that our two countries should curb methane emissions by undertaking regulations that would target oil and gas production. I haven't seen any evidence in your Yukon regulations of oil and gas production. I have not seen any evidence in those regulations that any extra effort is now being taken by regulation to curb methane emissions. Hasn't happened. Should. Finally, what does the science say about the negative impacts? Remember, the title of this talk is Negative Impacts, Bad Things. Don't take it from me. What does the science say? I'm only one scientist. I can't cover everything. What are the negative impacts on water, air, and human health, among other things? So an organization that I helped found back in 2010 is called PSE Healthy Energy. PSE stands for Physicians, Scientists, and Engineers for Healthy Energy. One of the most important things this organization has ever done, starting about 2 years ago, was to collect all of the known peer-reviewed literature. This is literature that's published in real journals. It's not bloggist shit. It's not somebody's opinion. It's not right-wing talk radio. It's not what you hear at a local bar. This is peer-reviewed literature published by bona fide scientists and engineers around the world. We've collected what we think is just about every paper that's ever been published in the area of shale and tight gas development. And we put them into a database online. And here it is. And it's very important for you in the Yukon, and you who are the regulators, I hope some of you are listening, the regulators in the Yukon, to understand that you now have one hell of an assignment from this professor. I like giving assignments. I'm a professor. I also like giving exams. So I hereby give an assignment to the regulatory authority of the Yukon that they have to read all 922 papers. But let's look at the history of those 922 papers. Here's a bar graph. In 2009, there were 6 papers. 6. Now, 2009 is 10 years after Texas started developing shale gas. It was 5 years after Pennsylvania and Ohio and West Virginia started developing shale gas. It was 5 years after British Columbia started developing shale gas. And nobody knew anything. There were only 6 papers in the entire literature. 6. The next year there were 6 more. Now there were 12. The next year there were 34 more. Now there are 46. The next year there were 73 more. And the next year 139 more. And the next year 201 more. And the next year after that, 256 more. So, I can tell you this. Over 50% of all of the knowledge that we have from these investigations reported in these peer-reviewed papers, over 50% of what we know, we've learned since 2014. Anything that happened before that was largely done in ignorance. Any regulations, provincial, territorial, state regulations, had to have been based on ignorance, because nobody knew anything. As of today, there are 922 publications in that database. To give you an example of the difference between a state that has been very, very careful and a province or a territory that perhaps is not being so careful, in 2008, my home state, New York State, declared a moratorium on fracking. Look, in 2008, there were only 6 papers. And yet New York State was wise enough, careful enough, and protective enough of its citizens to say, we don't know anything, so we shouldn't do it. As opposed to Pennsylvania that said, we don't know anything, let's do it. Ignorance is bliss. If you don't know that something is bad, go ahead and do it. Is that logical? The answer is no. But now, here you are in the Yukon, you're in moratorium for 1 more year. And so your regulatory authorities, your political leaders have to decide whether the Yukon is going to go ahead and develop shale gas. Excuse me, but here's the assignment. You better tell your regulators to go into this database and download all these 922 papers, because that is the body of literature on which the decision should be based. Not on opinion, not on politics, not on which side screams louder. Base it on science. So there's your assignment. There's your assignment. You make sure that your leaders, your political leaders, and your regulatory leaders know about this database. They cannot plead ignorance anymore. They can't say, well, we're not sure. Because let me tell you how sure we are. So this is what the database looks like. It's divided into 12 different categories. You pick. Air quality, climate, community, ecology, economics, health, regulation, seismicity, waste fluids, water quality, water usage. We divided up all those 922 into these 12 categories so it's easier to figure out what you're going to do. Here's Avner Vengosh's paper. You heard from him not too long ago. But we published a paper this year in which we looked at 3 particular topics: air quality, water quality, and human health. And we read every paper in each of those 3 topics. And then we categorized the paper as to whether the paper said, this is really bad, or we can't tell whether it's bad. And let me tell you what we found. Human health impacts. We found that 87% of the papers directly addressing human health impacts found bad human health impacts. 13% of the papers didn't find any bad human health aspects. But no paper said people are healthier because of shale gas than they were before shale gas. Nearly 9 out of 10 papers say bad things will happen. Bad things have happened. Bad things will continue to happen. Air quality, which of course is related to human health. 92% of the papers in the category of air quality found bad impacts, negative impacts on air quality. No paper published to date has said that the air quality near shale gas development is better than it was before shale gas development. That's impossible. Over 9 out of 10 say it's worse. Water quality. Nearly 3/4 of the papers have concluded that there has been water contamination due to nearby shale gas or shale oil development. What we're trying to figure out here is consensus. That's the way science works. You get a large number of scientists over a large area, geographical area, the US, Canada, Europe, and you look at the big picture, all the possible things that can happen. And you study those things over a long period of time, and then you publish. And you get reviewed, and you get criticized, and you hone in on the truth. And eventually, science always reaches a consensus, a yes or a no. In the meantime, there might be a maybe, there might be a probability, but eventually the probabilities become so significant that something is true that science declares it to be significant. Consensus has been achieved. I'm not going to sit here tonight and tell you that there is universal consensus yet. This is still only 922 papers, and many of these papers are the result of what are called longitudinal studies. They take years and years. If you're going to study health effects due to radiation or health effects due to ingestion of particulate matter, you can be causing health effects that don't appear for many years in a human. So you have to study a large number of human beings over a long period of time in order to make conclusive evidence, to get conclusive evidence that a health effect is actually true. So we're still at the beginning, but the problem is we didn't start until 2014. And there had already been 25 or 30,000 shale gas and oil wells in the U.S. So we might have already harmed people. The probability at this point is that we have harmed people before we knew any better. So let me summarize because I'm at exactly 1 hour. So because of spatial intensity, you know what spatial intensity is now, a hell of a lot of wells, a lot of pads in an area, and technologies of scale, shale gas and oil development requires everything to be bigger. Here's what's going to happen. The risk of groundwater contamination are very high. Not because of fracking, but because of wellbore integrity, loss of wellbore integrity, leaking wells, surface spills, and waste disposal. Those are the key issues for groundwater contamination. The impacts upon your landscape, I showed you what a pad looks like, and I showed you how close those pads are. It will be considerable and it will be permanent. The effectiveness of existing legislation and regulation. I have read the Yukon regs. They are poor. The word shale does not appear in your regulations. The word unconventional does not appear in your regulations. Your regulations have not been updated to account for modern development of oil and gas from shale formations. They are essentially the same regulations that were written for conventional oil or gas many years ago, and they have not been updated. I'm pausing for effect here. Our state of Maryland, which only has a relatively small amount of shale gas, and no oil at all, it's just shale gas. Only a very small percentage of our state of Maryland has it, just passed their modern regulations. And they are the toughest regulations on the face of the earth. If you want to see what tough regs are, go read the new regs published by the state of Maryland. For example, how close can a company drill a shale gas well to a private home in Maryland? 600 meters. 2,000 feet. I'd be willing to bet that there is nobody in the oil and gas industry who wants to operate in the Yukon who would accept that. They would say, that's too far. That would take so much land out of possible use, it wouldn't be economical for us to develop. Well, good. But it would be protective of your water and protective of your air. 600 meters. How about the potential net economic outcomes to the Yukon and the rest of your country? Well, I don't know if you noticed this, but the U.S. shale gas and oil have gone bust. Of all the shale gas plays in the United States, only one is still increasing its production. All the rest of them are in terminal decline. All the easy-to-get stuff has already been gotten. So, no, I can't imagine any company with any brains who would walk into the Yukon now and try to develop shale gas or shale oil with the prices that are existing. But as the prices go up, which they will eventually, some company's going to come in and say, let's try it. And you better be ready, hopefully, to say no. Because you're not going to get anything out of it. You're going to get all the pain and none of the pleasure. And finally, you know, because you're in a northern climate, you know that climate change is real. Global warming is occurring much faster in the northern climes than any place else on the face of the earth. You know that. You're experiencing it. Donald Trump wouldn't believe it, but you should. So you would be adding additional carbon dioxide and methane to the atmosphere if you allow this to happen in the Yukon at a time when we should be decreasing, not increasing, both greenhouse gases. The Yukon has to make a moral decision. You all have read enough to know that of all the oil and gas and coal still underground, 80% of it has to stay there. Of all the oil and gas and coal still underground, 80% of it has to stay there if we're going to try to make sure that global temperatures don't reach 1.5 degrees centigrade above the norm. That means that every region, every state, every province, every territory has to decide what part of our resources are we going to keep underground. New York has already made its decision. There will be no shale gas development in New York. New York has voluntarily said, we're going to keep ours underground forever. I would suggest to you that you should suggest to your leaders that given where you are in the Yukon, given the tremendous effort it's going to take, the tremendous amount of capital it's going to take, the tremendous difficulties it's going to ensue for the companies and for you, that it's ludicrous, stupid and ludicrous to begin to develop shale gas and oil in the Yukon. A few people will benefit, obviously a few politicians, a few oil and gas magnates, but the people of the Yukon, So, let me conclude there. I want to thank you all for allowing me to meet with you today. I'm looking forward to hearing some additional great questions over and above the ones you already asked me. And even after tonight is over, if I haven't gotten to something that you want to hear something about, or you want to read a paper, or you want me to point you to a particular set of papers, contact me by email and I'd be glad to get back to you. Thank you.
Dr. Ingraffea, you can hear the excitement and enthusiasm that exists here tonight about the presentation you've just given us. Maybe I should go over here because there's lots of feedback.
Yes, I can.
How are we doing? Okay.
Fine, I can hear you perfectly.
Dr. Ingraffea, you've given us so much information in such a wonderfully easy way for us to understand. We just appreciate your teaching style very much. We now have some time for questions of Dr. Ingraffea, and those of you who are in the communities, I just want to give you a telephone number to call if you have a question, and we'll pass it on. The number is 1-867-334-5778. 1-867-334-5778. And here at the Brinja Center, Jason will just go around with the mic, and any of you who have questions for Dr. Ingraffea are free to answer them, or ask them. I think you shouldn't answer them, though.
Hi, thank you very much. Did somebody here write down the website for the study citation database? Can we get that from Yukoners Concerned? We must. Can you, or if not, there. There it is. Thank you. Thank you. My question is, very early in your talk you said that how inefficient these wells were and that only about 10% of the gas what they could obtain. Is that why they go back again? Does more gas seep into that same cracked up zone that they can then access later?
As I expected, an excellent question. So the industry has been trying, what I would say is desperately, for the last 10 years to try to figure out how to produce more gas and oil from a given well in shale. They very quickly found out, as I mentioned, that what they're doing is inefficient. Only about 10% of the gas, only about 5% of the oil that's down there is actually coming back out of the well. So they've tried many different things. They've tried different concoctions of fracking fluid. They've now gone to much longer laterals. Initially, the laterals were only a few hundred meters. Then they became a kilometer. Then they became 2 kilometers, and now in some cases 3 kilometers. As the laterals get longer, they need more and more fracking fluid. So they've experimented with the order in which the fracks occur along a lateral. They've experimented with the spacing between adjacent wells. They've experimented with different combinations of chemicals injected at different times. They're doing everything they can in the research laboratories and in experimental wells to try to increase the efficiency. And in some cases, they've been rewarded with a 2 or 3% increase. But it's not, there is no way, I'm sorry. The problem, basically, I'll try to explain it to you again. Take a sponge. Go home and do this experiment in your kitchen or your bathroom. Take a sponge. Put the sponge under the faucet and turn the water on. Now, the first thing that happens is the sponge will absorb the water, and the next thing that happens is water will run out the bottom of the sponge. The water will go right through the sponge. That's an example of high permeability. Next thing I want you to do is take a piece of concrete, if you have one around the house, or a piece of ceramic, a plate, and put it under the faucet. And you'll notice that none of the water runs through the plate. It runs around it, but not through it. Because the plate, or the concrete, is basically very impermeable. It doesn't allow a fluid to migrate through it. Shale, the rock itself, is hundreds or thousands of times less permeable than concrete. So the gas or oil that's contained in the shale doesn't want to come out. The only way they're getting oil and gas out of shale wells is not from the shale itself. They're getting the oil and gas out of the fractures that are already in the shale. The shale is naturally fractured. and I can explain for hours why it's naturally fractured and the direction of the natural fractures. But the natural fractures are the reservoirs for readily available oil and gas. So when they first drill the lateral into the well and frack the well, they're really not fracking it. They're not fracturing it. It's already fractured. The shale is already fractured. All they're doing is widening the existing fractures so that the gas and oil that's stored in those natural fractures can migrate back to the well easier. But once that well has drained all those natural fractures, the rest of it is going to take forever. That's why you see rapid decline. We talked about that a half hour ago. The oil or gas that comes out of the well is very high the first day. By the 5th day, it's less. By the 100th day, it's much less. By the end of the first year, it's half of what it was. By the end of the second year, it's a half again. By the end of the 4th year, it's a 10th. All they've done is drained the readily available oil and gas. So, now getting back to your question, one of the other things they're trying to do is refrac. That is, they go back through the same well, possibly through the same perforations, possibly through new perforations at a different orientation, and frack it again. And what they have found is that in some cases they can again increase the productivity of the well. In some cases they do not increase the productivity of the well. But in the cases where the productivity of the well increases, it never increases back to what it was to begin with, and it declines quicker. So now the company is faced with a conundrum. They already invested in drilling the well, casing the well, cementing the well, perfing the well, and fracking it the first time. There went $10 million. Now they come back and they want to frack it again. Here's another $2 or $3 million. Are they going to get another $2 or $3 million worth of gas or oil out of that well? Maybe, maybe not. Wouldn't it be better for them to save that cash and go off and drill a new well? Because they know they're going to get more oil and gas out of that new well. That's their problem. They don't know how to allocate their capital in such a way that they optimize the return on that investment, because they don't really understand how to predict the productivity. All they know is that there's a physical limit. They're never going to get more than 10, 15, 14, 16% of the gas, 5, 6, 7% of the oil. That's the best they can do. It's the best they'll ever do. Long answer to your great question.
Thanks very much, Professor, for your presentation tonight. I have a question for the audience, or a couple of questions for the audience. First of all, is there anybody from the Yukon Oil and Gas branch here tonight at this presentation? I don't see any hands going up. Is there anybody here from the Yukon Party government? Again, I don't see any hands. Is there anybody here from the Liberal Party or the Liberal Party candidates? Are there any of them here tonight? I see no one. And I do see several NDP candidates here and MLAs here. I just wanted to point that out.
By the way, I presume that the answer to all those questions is no, and I can tell you I'm not surprised. It's very rare, extremely rare. I've given over 200 talks like this since 2009, and I can count on one hand, actually I can count on less than one hand, the number of times that somebody from the oil and gas industry showed up and admitted that they were from the oil and gas industry. It's embarrassing for them, because if they come and identify themselves, well, they might get asked questions. And if they come and don't identify themselves, then they have to go back and report what they heard, and they're not going to like what they hear. So ignorance is bliss. Let Professor Ingraffea talk to the masses. We don't care. But I can assure you that somebody's listening, live streaming, and I repeat what I said during my talk. Anybody from the oil and gas industry, whether it's Canadian or U.S., if you're listening right now, and if you think I said something that's incorrect, contact me directly. Be professional. I've been a professional. I worked with you guys for 20 years. You're the best and the brightest, and I'm not kidding. I have great respect for you as scientists and engineers. So if you think I said something wrong, correct me. Call me, email me, we'll have a discussion.
I just want to say, too, that I felt that I was pretty well schooled on this topic, and watching the presentation tonight has been even more discouraging for me.
Well, I learn something new every day. Don't worry about it.
Thank you very much, Professor, for your
Thank you.
information and presentation. I've saw and listened to you for a couple of years now, so it's I just thank you for being here. And I am one of the 6 NDP MLAs here in the crowd, and I know we have one Green Party MLA, and that's candidate, and then there's incumbent politicians here from this party of the NDP. But just to acknowledge those folks here, I want to make that clear. My question is, on your presentation when we were talking about the lifespan of the cement casings, I believe that you had said it's around 1% that fail right away, and then so 1 out of 10 would be defective. What is the lifespan of a cement casing in a perfect world, and knowing that the fracking fluid, there's I believe about approximately 20% does not come back out for the leaching pits. So what can we, in our best scenario, knowing that this fluid's down there, that this cement casing, on a perfect world, I think it's 50 years, and please correct me if I'm wrong. So I'd just like some clarity on that for people that, and myself, around the lifespan of a cement casing.
Actually, I think I heard you ask me at least 2 questions, one having to do with the longevity, the expected structural longevity of a well. What can one expect from the casing and cementing if it's done correctly to begin with? Can one expect that well will function correctly forever? No. The answer is no. The longer a well is in service, the higher the probability that eventually there will either be a cement failure or a casing failure. That's well known in the industry. Everything put together sooner or later falls apart. This is a man-made structure put underground, where it's going to be subjected to earth movements. It's going to be subjected to a wide variety of gases and fluids. So corrosion. The cement, as I said, is nothing more than cement powder, water, and a couple of chemicals that are added to try to decrease its permeability and decrease its shrinkage, but it does shrink. It does disbond from the casing and disbond from the rock. It can crack over time. Casings will corrode over time. So there are literally hundreds and hundreds of papers in the industry literature studying the longevity of wells. If the well is very well done, and if you're lucky, 40 or 50 years, no leaking. After that, I don't know of anybody who's monitored any particular set of wells for more than 40 or 50 years. What is known is that the older the wells get, the higher the probability there's going to be a problem. And as I pointed out on this slide, where we studied Pennsylvania in particular, because we wanted to look at a place that had really tough regulations and was doing very modern shale gas development, what we found is in some regions where the geology was very challenging and the rate of drilling was really high. In other words, a lot of companies went into one small area, drilled many, many wells in a very short period of time because the gas prices were very high. They wanted to take advantage and get the profits. 1 out of every 10 wells was leaking within a few years. And so as time goes on, more and more of those wells will leak. There have now been studies done, both in Canada and in the US, surveying old wells, trying to find old wells, and trying to figure out what percentage of those older wells are now leaking. And what was found in Canada and the US is a significant percentage of wells that have been out of production for decades. They go back and find the wells when they can, If the well's older than 30 or 40 years, they might not have good records as to where these wells are. But when they go back and find these wells that are 30 and 40 years old, have been out of production for 20 or 30 years, a very significant percentage is leaking. Leaking methane, leaking oil. And then the problem is, well, how do you fix the well? And as I indicated in my talk very briefly, it is possible to fix a well that's leaking. But there's no guarantee that an attempt to fix a leaking well will be successful. Industry statistics are about 50% of the time when they try to repair a cement job, it works. 50% of the time it doesn't work. And one other thing that I want to confirm and clear up here, you're going to hear the word plugging. So your regulations talk about plugging wells. Now, to the layperson, you think plug. Plug means to stop, right? You plug something, you stop it up. So if a well is leaking and you plug it, it's going to stop leaking, right? No. No. A well can be leaking from inside out, or it can be leaking from outside. When you plug a well, all you're doing is pouring cement down the inside of the well, trying to plug it so that nothing comes up the inside of the well. But if the well is already leaking outside, plugging doesn't help. So you might go off, your government might go off and find a whole set of old leaking wells and spend anywhere from $10,000 to $100,000 plugging one of those wells and find out that the plugging had absolutely no effect on the leaking.
The good doctor answered my question. I wanted to know about orphan wells, so you've answered my question. Thank you.
Thank you.
Is there any research of fracking done in permafrost areas, and does that make the issues worse?
You know, it's a great question, and I should have done more homework to answer that question. I don't know the answer to that question. I don't know. Perhaps somebody in the audience does. I'm thinking both onshore and offshore. You're talking permafrost. Certainly the wells offshore in Alaska have been fracked. I don't know if there's been fracking in permafrost areas in Canada or in the U.S. I should have done my homework to figure that out. But as you can imagine, your regulations, when I read the regulations, it does talk about the difference between a well in a permafrost area and a well in a non-permafrost area. So your regulations differentiate between the two. They differentiate the casing design and the cementing design in conditions in which you're drilling in permafrost. So given that that exists, I'm assuming that since your regulations address drilling in permafrost, there must have been wells drilled in the Yukon in permafrost areas, and if there were wells drilled, even if they were conventional wells, they were probably fracked.
My question is, I've seen several times in the presentation that radioactive materials are included in the wastes. I would assume uranium most likely, but could you expound on that, please?
Okay, I didn't get the whole question, but I think you're asking about radioactivity in the waste?
Yeah, the radioactivity in the waste.
Yeah, so let me try to clear things up here. Shale, I'm talking geochemistry here now. Shale is naturally more radioactive than most other types of rock. Now, I just said, I'm picking my words very carefully, more radioactive than most other types of rock. I didn't say that it's highly radioactive in the sense that if you had a piece of shale in your hand, you'd be subjecting yourself to radiation poisoning. What I am saying is that when a company goes into an area in which they're not sure exactly where the shale is, during the drilling process, they will have a tool that is down the well that is detecting radiation. And they know, since the shale is more radioactive than the rocks above it or below it that are not shale, when they detect an increase in the radiation, they know they detected shale. Now, when they drill into the shale, Remember the picture I showed you? You drill down vertically, then you drill laterally 2 or 3 kilometers. All that rock that you've excavated from the shale through the drilling process that comes back up the well, that crushed shale has whatever the native radioactivity. It's called naturally occurring radioactive material, NORM. That material, if it's concentrated, can create a condition of radioactivity that might be harmful if it's ingested or breathed. I'm not an expert on radioactivity. I'm telling you what I've read in some of the papers in this database. I'm looking at a Geiger counter in my office right now. Got one right under my desk. And I have gone to places in Pennsylvania where I know that companies have dumped flowback along the roads by accident. I've watched them dump it by accident. In other words, you leave the valve open on the back of the truck a little bit, and as you're driving down the road, the truck is actually emptying itself along the road. I've watched them do that. I've also gone to a garbage dump in Pennsylvania, which is accepting shale waste from Pennsylvania. In Pennsylvania, they have radiation detectors on their garbage dumps, and if the radiation is too high, they won't accept it. But New York accepts it because they're run by the mafia here. So I've gone to a garbage dump with my radiation detector, and I've gone to these roadsides, and I have detected higher than background level of radiation. Higher than background. Is it high enough that it's dangerous to humans? No. So what I read in the literature is that the danger occurs when the liquid, the flowback that's coming back out of the well after fracturing has been down there for days or weeks or months. It's absorbing the radioactive material from the shale. And that liquid comes back up through the pipes and deposits itself as scale. Like the stuff you have in your bathrooms and I have in my tub. The scale that accumulates when liquids evaporate. And that scale can accumulate and now become a concentrated form of radioactivity. And that can be dangerous to the workers. That's what I know. So there are other studies that have been done on radon being carried by the natural gas. There is radon that comes out of the ground with the natural gas. Radon is a very dangerous radioactive material, causes lung cancer. Second leading cause of lung cancer in the United States, radon gas. The radon dissipates. It decreases its radioactivity very quickly within a few days. There's a half-life. But if you're using gas coming out of shale within the first 2 or 3 days it's coming out of the ground, it might have a higher than normal level of radon in it, and it could pose a threat to human health. These are studies that are ongoing. You can read about everything I'm talking about. You can read yourself in the papers in these databases. Go to the human health section and search on radiation.
Well, thanks, Dr. Ingraffea. Good presentation. I've been introducing your information here through many years into the discussion. I have one brief question on regulations on oil and gas legislation. And I thought it was great that you pointed out that the Yukon Oil and Gas Act does not even mention shale. It also does not mention conventional or unconventional or fracturing in any kind of a meaning. And obviously the legislature must know something about the impacts because they also removed the CASCA First Nations oil and gas development veto right in the amendments. So basically a future government could oppose fracking and blast the Jesus out of this territory, both at the same time. If you look at the terminology of the Oil and Gas Act, that doesn't mention any of the substance. Are you aware of any other oil and gas legislation? I mean, here it was voted in by all parties. Are you aware of any legislation piece that is as deceptive as this Yukon legislation, oil and gas?
I have to admit, I'm sorry, I can't hear you very well. And your question has something to do with regulations?
Legislation that is as deceptive, as misleading as the Yukon Oil and Gas Act, that doesn't even recognize the reality or the aspects of fracking. It does not have the word shale in it, as you pointed out. It does not have the word conventional or unconventional in any meaning. It does not mention fracturing. So basically, it just talks about oil and gas wells, which is highly deceptive. So basically, a government could oppose fracking and open the door to fracking, both at the same time, with this Oil and Gas Act. Are you aware of anything as misleading, as bad as our Oil and Gas Act?
So the only part I didn't understand is the last question you asked me. Am I aware of what?
Are you aware of any other similar legislation that is as misleading as what the person?
Oh, yeah, Texas. Every time I read the Texas regulations and look and see what their standard practice is, I'm just amazed. Because Texas has more oil and gas wells than any place on the face of the earth, probably. And they're basically operating back in the 1960s and 70s. In contrast, I should point out, if you want to see what I think is a very good, not perfect, no province, no state, no territory has perfect regulations, but look at the regulations coming out of New Brunswick. And I already recommended that you look at the regulations that just came out of our state of Maryland as examples of thorough, well-researched, well-supported by the science, regulations that are aware of the differences between conventional and unconventional development. So the answer to your question is, when I read the Yukon regulations, I read regulations in many states, many countries, and you have a lot of work to do. If you want to do shale gas and oil development in the Yukon, boy, I hope people start putting their reading glasses on and reading what's happening in other places. Start with New Brunswick, look at Maryland, and go from there.
I'm a Yukon First Nations person, born and raised. My question to you is, how do we empower the people to completely dead halt it so that it does not happen in the first place? That we need to develop regulations.
I hear your question.
And also so that we don't need to learn about whether the gas well leaks, and that we don't need to learn about the potential impacts on human beings and the earth, the land, the water, the animals. How do we just stop it completely in its tracks?
I'm going to try to answer your question by giving you an example of my home state of New York. And I'm glad to hear that you're from your First Nation, because in 2008, among the very first groups of New Yorkers who began to protest, I'll define what I mean by protest in a minute, shale gas development, was the Onondaga Nation. I live 20 miles from the Onondaga Nation. That's one of our first peoples. They have a very large area in central New York between my hometown of Ithaca and the major town of Syracuse, New York. And they went to our capital. And they were a prime target for what we call Marcellus gas development. The city of Marcellus literally is in the Onondaga Nation. So they were among the leaders of what became, now I'm going to answer your question, what can you do? What should you do? Now, obviously, the political system in the Yukon is different than the political system in New York. The political system in Canada is different than the political system in the United States. But supposedly, we're both democracies. So what we did in New York State is to use democracy. When our regulatory agency was given the task, thank God they were given the task, of writing an environmental impact statement for shale gas development. By law, they were required to publish the draft of that environmental impact statement And by law, they had to accept public comment. So in 2009, they produced the first environmental impact statement pertaining to shale gas development. It was about 400 pages long and about 20,000 comments. The people of New York State wrote 20,000 comments. And by law, every one of those comments has to be read and reviewed. And so about 2 years later, our regulatory agency published a second draft. It was 1,000 pages long. And they got 60,000 comments. And in 2013, they published the third draft. And they got 120,000 comments. So I'm answering your question by saying exercise democracy. Again, I don't know exactly what the procedure is in the Yukon. I'm imagining that you have the opportunity to give input to your regulatory authority as to the content of your regulations and also as to whether there has been an adequate environmental review done of unconventional development of oil and gas. Those are your two targets. Target the regulations and target the environmental review. If both of those have to be redone, and I'm telling you, your regulations need to be redone, so you should be writing comments by the thousands to your legislators and to your regulatory authority and say, look, these are ancient regulations. They were written at a time for conventional development. They don't mention shale, they don't mention they don't mention unconventional, they don't address high volume fracking, they don't address multi-well paths, they don't address clustered paths, they don't address what you're going to do with a large volume of waste. These are unacceptable. And I don't know where you are in the timing of environmental impact statement. I don't know whether that has to be done before you can have shale gas development. We were lucky in New York State. We had to do both things. The first thing that we had to have was the environmental impact statement, and it was never accepted. After 3 tries, from 400 pages to 1,000 pages to 1,500 pages, our regulatory authority threw up its hands and gave out. They literally gave up. We won. The people won. We told them, nope, not good enough, try again. Nope, not good enough, try again. And no, definitely not good enough. So the next thing they did was they tried to circumvent the law, which says first you have to have an accepted environmental impact statement before you can publish regulations. Since they never got an accepted environmental impact statement, they went ahead and published regulations. And they got 100,000 comments. At that point, our governor said, the hell with it. We aren't going to do it. We won. Out of the people. Now, it's easier said than done. Remember, to generate 120,000 comments means that literally hundreds of grassroots organizations like yours operating all over the state of New York. We have 19 million people in this state. There were literally hundreds of organizations. They had to collaborate, coordinate, get their act together, decide on a strategy, which we did. New Yorkers against fracking. And I was very pleased to hear that you're going to have 30 days of comments before your territorial elections. We did the same thing here. Every time that something had to be done, they always scheduled it around Christmas, thinking that we weren't going to be able to do anything. They always do that. I don't know if you noticed. It's like sneaking in the back door. They would publish something and say that all the comments are due on the 26th of December. So we said we knew that was going to happen, so we had, I don't know, was it 30-day or 60-day, and Dr. Sandra Steingraben, you probably heard of her, led an effort from jail. At that point, she was actually in jail, having been arrested for about the 3rd or 4th time. Led a campaign in which literally thousands of people every day would write in response to one of her suggestions a set of comments to go to our regulatory authority. We beat them to death. We just beat them down. And of course, the people in Pennsylvania at this point, what was happening just south of us, was so horrendous that all we had to do was wait for the next headline in the newspaper about another well explosion or somebody else killed on a well pad or another 15 families losing their water, or families not getting their rightful royalties, or some company dumping stuff in people's backyards. I mean, the industry was shooting itself in the foot. All we had to do is bring to our capital, Albany, all this information about all the bad things happening in Pennsylvania, and at the same time we're saying we don't want that here. And eventually our governor just gave in and said, yeah, well, okay, whatever, fine, no shale gas.
Okay, I just wanted to check in and make sure.
Let me add one other thing. There's a commonality between the Yukon and New York, believe it or not. I don't mean to be insulting. The total volume of shale gas that could possibly be developed in New York is relatively small compared to what's in Pennsylvania or Ohio or West Virginia. It's significant, but it's relatively small. I've looked at the maps of the Yukon, and I've looked where the shale is. Here, hold on. Yeah, I'm a member of the Society of Petroleum Engineers, so I get all their insider information. So here's the world map of shale gas development. So I go to this map and I look and see, well, what do they have in the Yukon? And then I go online and I do some research and I call my friends in the industry and I say, well, how much oil or gas is there in the Yukon? Potentially. And they say, not very much. So another angle you can play is who's going to benefit from such a relatively small amount of oil or gas that's going to have to be extracted with extreme measures, given the kind of climate you have for most of the year. The farther north you get, the more challenging it gets to develop oil and gas. Is it really, you really want to take that chance? It would be one thing if you were, quote, the Saudi Arabia of natural gas in Canada. You're not.
Okay, we still have lots of hands up. I want to make sure that you're still able to stick with us. I know it's approaching midnight. Are you able to answer some more questions?
I can take a few more. Yeah, my wife hasn't beaten down the door to my office yet.
Okay.
Thank you for the stay.
But if I need a divorce lawyer tomorrow morning, you're paying for it.
Okay, I have two quick questions. First is related with the health issue. Where's the community about the health? The doctor, the cancer, all the family, they get muzzled by this industry because all the liquid, we never know what type of liquid they shoot underground, and the way you explain with all the the reaction of the radiation. So partially I understand, but the other side we never hear about how many work compensation problem and how many. It's a disaster to me. It's looked like we let smoking allowed, and now it takes 50 years now to say, well, smoking, sorry, it's not good for you. So it's sort of the fracking is worse than regular mining people. But along the way, we're standing all the doctor around the world and looking that thing and say, well, this is a disaster, will cost billion and billion money on this society.
So I'm not sure I got all that question. I think that I understand the question, and I want to point out that in Pennsylvania, again, that's the state just to the south of me, where there have been about 10,000 shale gas wells drilled since 2004. The vast majority of the doctors in that state had no idea. They had no training. They had no education on what kind of physical harms could come to their patients because of shale gas development. So in most cases, they were not able to recognize a relationship between an illness and shale gas, where they could not diagnose what was going on because they didn't have any idea of what was coming out of a well in the air or getting out of a well and into the water. And it got very serious in about 2013 when the conservative Republicans took over in Pennsylvania. They were all for more shale gas development. And they literally passed a law in our state of Pennsylvania that says that if a patient approaches a doctor in the state of Pennsylvania and complains about some health effect, allegedly from oil or gas operations, that doctor was not allowed to be told by the oil or gas company what chemicals they were using, unless that doctor signed a non-disclosure. Do you hear what I said? Patient comes into an office, I think I'm sick. I know I'm sick. I think it's because of oil and gas. And the doctor says, well, I need to call and find out what you've been exposed to. What chemicals have you been exposed to? The doctor calls the oil and gas company. The oil and gas company says, I can't tell you. I know you have somebody who's sick in your office, but I'm not going to tell you what chemicals we use unless you agree to sign a non-disclosure. You can't tell your patient, nor can you tell another doctor or the public what we're going to tell you. And that rule stayed in effect until this week. The Supreme Court of Pennsylvania overturned that. It took 3 years to go forwards from going backwards. So I think the point you were making is that there are so many possible things that can go wrong chemically with all the materials that we inject into the wells, combining with all the materials that are naturally in the wells, coming back up and now having to be captured, stored, and transported. There's so many different chemical reactions that can occur and so many harmful things that can happen along the way that we're just learning about these things after all these years. And doctors now, finally, health professionals, have begun to publish widely. As I said, you're looking at the database and there's a whole section here on health. Oops, I'm not online. There are hundreds of papers in this health area. Most of them published in the last 2 years. So I'm going to add something to the question that was asked me by the First Nations person. Another angle you should play, which we played in New York to great effect, is to organize your public health professionals. There's an organization in New York called Concerned, CPNY, Concerned Public Health Professionals of New York. They published a compendium, perhaps you know about it. It's on its 4th edition. The compendium from CPNY, Concerned Public Health, whatever, I'll look it up for you. They've collected literally thousands of documents. In addition to the peer-reviewed documents that we've collected, they've collected everything: newspaper articles, magazine articles, doctors' reports, and they assembled that into a compendium that was literally 8 inches thick. And they took it to our Capitol and handed it to our governor. And they took it to our Capitol and handed it to our director of public health. And took it to our Capitol and handed it to a director of our regulatory authority and said, we're health professionals. We are responsible for the health of the people of New York. And we don't know what we need to know. We're just beginning to find out all these bad things. So stop, don't do this until we know better. So I would strongly advise that you, if you haven't already done that, to enlist the support of the various health organizations that you have in your territory. Doctors, nurses, public health officials. Get them on your side.
Dr. Ingraffea, thank you for your work. We much appreciate it. I'd like to comment that governments can make regulations or laws or do inquiries, and all that is useless if we sign trade agreements. A company that say an American company operating in Canada, even now under NAFTA, can sue Canada for any rule or law which interferes with their profits. And all the trade agreements have this provision for suing. So if we sign trade agreements with Asia under the Trans-Pacific Partnership, for example, we couldn't stop, for example, Petronas that wants to frack on Lelu Island in BC. They've already started exploring. If we pass laws for preventing them, and we've signed the Trans-Pacific Partnership, they can sue for enormous amounts of money. And often governments won't even pass a law because they're afraid of having to pay all that money. So the trade agreements just prevent governments from acting, and we must not sign them. Thank you. And if you have any comment about that, then that would be welcome.
I didn't get all of your questions. Sometimes I can't hear what's going on because maybe you're not holding a microphone close enough or something, but your comments about the Trans-Pacific Partnership and the dangers it brings to people concerned about the environment because of lawsuits that could be brought by foreign companies that would contravene our own regulatory authorities and our own regulations is pitiable. It's absurd. So as you know, the TPP is a very important part of the debate in our current presidential elections. Yes, I agree. It's a dangerous thing. I would hate to see a situation where New York State gets sued by a company in the TPP, a country in the TPP, because New York State refuses to produce its shale gas. I would hate to see the Yukon produce shale gas and export it to one of the TPP countries. Why is that a benefit to you? I don't understand why that's a benefit to you, and then you might get sued because you're not doing it, or you might be sued because you're over-regulating it. No, I agree. Absurd.
Thank you very much for your presentation, Dr. Ingraffea. It was, I'm not sure it was enlightening, but it was, it was great to see you in person, almost. I've been concerned about the increased seismicity, and your graph confirmed that. And I've been following it a bit in northern BC. And I think there are some now that have been over 5 in magnitude.
Yes.
My question is that
there's been a 5.6.
Yeah, the media
in Texas,
the media,
and a 5.6 in Oklahoma.
The media and industry says, well, there's not much worry because they're all small scale. They're 3, 4 magnitude earthquakes, and there's been no. And the media always reports that there was no damage to infrastructure or injuries to humans. My concern is what's happening to well integrity. Like how well can the casings, the cement casings, withstand even a microquake? And is anybody studying these in, say, the swarm zones of Oklahoma?
Excellent question. And as a response, I will point you to reports from the British Columbia Oil and Gas Commission, which point out that earthquakes in the lower 4s have, in fact, destroyed wells, gas wells, because of the earth movements. Obviously, it should be obvious, the closer you are to the center of the earthquake, the more the motion is. And if you're creating a quake from fracking itself, you should expect that the highest motions are going to occur right around the well. And you, as I said, you have multi-well pads, so you might be creating a quake from fracking a well, and the well immediately adjacent to it, perhaps only 150 meters away, is going to experience significant earth movement, and you can have the casing collapse, you can have the cement cracked, and that's been observed. You're correct in pointing it out. So the damage to underground structures, maybe there's no significant damage so far to above ground structures, but the damage to underground structures can be significant and dangerous. And as I pointed out, I'll repeat, the 4.8 caused by fracking is larger than most of the quakes, larger than the vast majority of the quakes caused by underground injection of waste.
Yes, Dr. Graffia, thank you very much for your presentation tonight. Question is, most of the pictures that we see of the drill sites and the pads and that is on prairie lands. I'm wondering what the experience is in history on drilling in mountainous areas. The drill that you set over Carcross was certainly in a very, very mountainous area. How does that affect the differences between that and in the prairie provinces, prairie states?
Excellent question. And I wish I had some other slides I could show you. So Pennsylvania is also mountainous. Now there's mountains and there's mountains. So Pennsylvania is crisscrossed from northeast to southwest with what are called the Allegheny Mountain Range. And some of these mountains are 3,500, 4,000 feet. And typically the companies will drill on the top of the mountains first. I'm pausing for effect. The reason is one of the crucial contributors to the productivity of a shale gas well is pressure. There are three things that are absolutely essential to get a shale gas well to be productive. Number one is that you have to have shale that has gas or oil in it. Not all shales have gas or oil. Some of it's been cooked out already. It's gone. It's migrated into some sandstone or some carbonate rock. So if there is no gas, no shale, you're not going to get any. The second thing is the thickness of the formation. The thicker the formation, the better. And the third thing is the pressure in the formation. What is the earth pressure in the shale? The higher the pressure, the higher the productivity. Because when you punch a hole in it, the higher the pressure, the faster the gas comes out. Make sense? So where would the pressure be greater? If you have a well below a mountain, if you have a well below a valley? If you got an extra 2,000 or 3,000 feet of earth from the mountain, you're going to have higher pressure. So I can show you lots of pictures of pads all across Pennsylvania that are drilled on mountaintops. I can show you lots of pictures in West Virginia, which is extremely mountainous, where they will go to no end to excavate large amounts of earth from the side of a mountain to create a pad large enough to drill multiple wells. Now, earth moving is no big deal for the oil and gas industry. If you want a job as an earth mover, go to work for oil and gas. So unless we're talking about, steep rocky outcrops, any kind of topology that can be where you can have earth moving equipment operating, or if you can get to the top, it will be accessible.
Okay, so we'll just
some states do have regulations. Some states in the U.S. have regulations that restrict development depending upon the slope. Some states do, some states don't. So, and again, I don't think I read anything in your regulations about that. You might want to check.
Why do they have to use fresh water and not seawater, for example?
Another good question. Okay, so one of the major discoveries that unlocked shale gas and shale oil was what's called slick water. So conventional frac jobs do not use water. Conventional frac jobs use concoctions of certain chemicals. Now, the chemicals have to be sufficiently viscous. By viscous, I mean thick, like molasses, or like silly putty, that you can inject down, that can carry the sand that's used as proppant, and sufficiently slick so that it can go into a well under relatively high pressure. But then once it gets into the sandstone or the carbonate rock, it chemically changes into a liquid. Okay, that was typically what was done in conventional fracking. Goes down as a gel, comes back as a liquid. When they tried that in shale, it didn't work. This is the early 1990s in Texas. And so people began to experiment. They tried different concoctions of chemicals. They tried liquid carbon dioxide. They tried liquid propane. They tried napalm. And eventually one guy said, you know what? Why don't we just use one hell of a lot of water? Huh? Water? You're going to inject water down a gas well? Typically, to kill a well, K-I-L-L, to cause a well to stop producing, you inject water into it. And now they were saying, well, let's use water for a fracking fluid. How's that going to work? Well, it did. They couldn't force enough water under high pressure into these long laterals. Excuse me, I'm losing my voice. So they went back to the drawing board and said, well, we have to make the water slipperier. So they added a lubricant to the water, and they called it slick water. Slick water, right? Lubricant plus water, slick water. And that was the solution. Different companies use different lubricants, but it was viscous enough to carry the proppant. It was slick enough that they could inject large volumes of water over long distances in a small diameter pipe under very high pressure, get the job done. Getting back to your question, salt water doesn't work very well with the lubricants that they have. Some companies have experimented with using salt water, but they have to change the chemistry of what they're using, and it gets more expensive. So it is possible that they can use salt water that's not as salty as seawater, but it's going to cost more money than using fresh water. Some companies have experimented with using flowback itself. They slightly process it, filter out some of the particulate matter in it, add some chemicals to change the chemical makeup of it, and they re-inject that as fracking fluid. So as I said before, there are all kinds of research, all kinds of experiments going on all the time to do two things: decrease the cost, increase the productivity. So in places where getting fresh water is difficult, they've gone to great lengths to try to use salty water, brine, or use treated flowback. Where water is readily available, Pennsylvania, except this summer when everybody went dry. You know, our rivers and streams are really wanting because we had the driest summer on record here. Except for this summer, there was always plenty of water. So nobody bothered with experimenting with brine, salty water, or reuse of flowback. Texas, different story. You know, farmers in Texas were literally selling their livestock, closing down their cattle ranches in order to sell the water that they had that they were giving to the cattle to the oil and gas industry. And Texas, except for up until this year, had a very long drought, 5 years, historically high drought, at a time that there was all that fracking going on. So there they were experimenting a lot with using briny water. But the short answer to your question is it depends upon the chemistry. If they can get the chemistry to work with salty water, they will, but it costs more money.
It's looking like I might be.
Can we? I'm looking at the time. Can we do say one more question?
Yes, it's looking like I might have the microphone for the last time pass around. Your presentation has just been the best presentation that I've been at for years, in actual fact. And I wish that we could.
I didn't hear that.
I'm wishing that we could gather enough money together here at some time or other with this, in this particularly beautiful part of the world. Oh, I've not been talking straight into it. I'm wishing that we could get some money to. Can you hear me?
No.
No, you're not here. Okay. Can you hear me now?
No.
Can you hear me now? I'm not sure what's happening to this microphone.
what percentage of all of the methane that is being emitted or coming out of the earth right now is in North America?
Huh. Excellent question. I don't know the direct answer to that. I did refer in my talk to the paper that was published last week that investigated, let me get to it, this. Why are we seeing this very substantial increase of methane concentration in the Earth's atmosphere? And they pointed out that it fairly conclusively, obviously I'm prejudiced here, fairly conclusively that they think this is mostly due to increased oil and gas production from shale in the United States. So the direct answer to your question, how much of this increase is because of the US, I don't know. There's obviously been a tremendous amount of oil and gas development, even from shale, in places like Argentina, in Canada, a little bit in China. We think some in Russia, but we're not sure. But overall, the amount of oil and gas development in shale has drastically increased around the world since roughly 2006. So I made the comment that the U.S. is significantly responsible for this, but how much, I don't know. I don't know how they could do that. I know that there are papers that you can read about in our database where they have been using satellite measurements now, most recently, to overfly large regions of North America. And the satellites have detected very high concentrations of methane, no surprise, over the Bakken, right? The Canadian side and the American side of the Bakken, the Eagle Ford in southern Texas, and the Northeast where the Marcellus is. That's what the satellite imaging is showing. And I think I need to quit because it's getting really late here.
Dr. Ingraffea, if you can hang in there for 1 minute with us, we'd appreciate it. I had a message just now to tell you that if you can ever get to the Yukon, we have a few volunteers who would take you fishing.
Wonderful. I will come someday. I would love to.
Just one minute. I wanted to remind everyone again that about the email sign-up sheet. If you want to be on the newsletter for Yukoners Concerned, you're definitely welcome to sign that. And also to say to the rest of the audience who have hung in there with us, there were about 100 to start with, Dr. Ingraffea, and a few people have had to leave. But I want to thank you, and Yukoners Concerned thanks you for your interest in this topic and for coming tonight to hear this information on fracking. We encourage you to do two things. Talk to your friends and neighbors about this issue. People need to know about this. And secondly, ask your local candidates in our territorial election about their position on the issue of fracking, because that is probably the most important one that faces the Yukon today. Dr. Ingraffea, we appreciate the time that you've spent with us so much, and we admire the work that you continue to do on this important issue. Your stamina, although I hesitate to use that word after the presidential debate on Monday night, is amazing.
No, it's my looks. It's not my stamina, it's my looks.
Okay.
Thank you very much. Good night, everybody.
I know it's way past your bedtime, and so we'll say thank you one more time and wish you well in your ongoing work in this field. Thank you so much.
Thank you, and good luck. Good luck keeping shale out of Yukon.
Jackie wanted me to let you know that you can look at this presentation online if you go to YouTube. Yukoners Concerned.